right.
All right, so this is the beautiful campus of University of Wisconsin-Madison. We're here on an isthmus between these two bodies of water. This place, I don't know if you see my mouse, but this place here is Memorial Union on the lake. It's a beautiful place to be in the summer. Looking forward to being there soon. So yeah, I'm here to talk about Platform X, which is our persistent computing and secure data enclave that we developed here at the School of Medicine and Public Health. Um, I'm sure many of us have lived through this before in the bespoke era of investigator goes out, buys a computer with their grant, maybe sticks it under their desk, or they hand it to you. They expect this server to be available to them exclusively for 10 years or more. Who knows? They probably have admin privileges on this thing. They can install whatever they want. Security's a nightmare. Um, Somewhere down the line, people come and go. You don't even know what these servers are anymore. They have obscure names. And we certainly had that here in the School of Medicine. We actually were 21 different IT departments within the school. A couple of years ago, we consolidated those 21 departments into one large IIT group. And so we've inherited a lot of this kind of stuff. And so we've been migrating people to more of a platform approach. And so the one I'm going to talk about today is what we call Platform X. Honestly, I think this was meant to be a placeholder, but then we talked about it for so long, it kind of stuck. Doesn't really have a meaning, but it was a placeholder. Um, but here's what it is today. So we have these colors make a have some meaning, right? So this red one this is where all of the data, this is where all this really secure stuff is. So we have connectivity to our health system partner in UW Health. We have data engineers and data analysts who operate within this environment, and they use Data Factory, which is an ETL or extract, transform, and load, or a data integration tool that pulls data from these clinical data sources. They populate a data lake, and then they transform those data into OMOP, which is a commonly used data model in the clinical research space. It's kind of an open source model. A lot of people use this to share data, and we do that with for example, like all of us. We have a clinical research data services team. This is again those data analysts who work closely with uh, the researchers who are requesting clinical data from our health system partners. They query those data sources, and then they provision data to what we call these data science dry lab suites. And I'll get into a little bit more about what those are, but these are unique kind of computing environments for each research project that we can tailor to whatever their needs are. And again, I'll go into that more detail later. All of the data, pretty much all the data then that the researchers interact with come in and go out via Globus. So we have audit trails, and we keep a copy of every bit of data that leaves the platform. So if there's ever a question as to what may have leaked or left the platform, we can investigate that and find it. We have an honest broker who reviews the transfer logs to make sure that people are doing things appropriately. The data engineering team then also provisions what we call data commons, and these are like disease specific data lakes, databases that may bring in data from a number of different sources, usually around a specific disease, like cancer. Might be broad as cancer, could be really specific like colorectal cancer. And then they can do some further transformations, and we provide some Power BI ways of visualizing kind of what data are available. And then we have been expanding our web hosting capability. And so these yellow ones mean that these are really meant for researchers, and this is where they live. The green things are really a little more on the internet. They're accessible to people off the platform. So we host like our CBOL portal, our RedCap here, and then we use Azure Functions, which are kind of they're really inexpensive compute on demand to do a bunch of different kind of integrations we have within our different clinical trial management suites. I should say, if anyone has any questions while I'm giving this presentation, feel free to interrupt. And I'm happy to stop and answer those questions as we go. Otherwise, I'm happy to answer them at the end as well. So Platform X is it's a diverse set of. It was meant to support a diverse set of computing needs, and this really came out of a request from our health system partner. Again, they were concerned that this data that was their patient data was kind of being thrown over the fence to the school, to the university, and they didn't know where the data was going, and they felt like it had kind of gone to the Wild West, and they were concerned about leaking of data, and so they asked us to build a kind of a secure a walled garden to protect this data. And so we started working with them initially to talk through the security and how we wanted to do things. And that was about 5.5 years ago at this point. And so we built this to provide a lot of flexibility for our researchers, so we can support a lot of different needs. We kind of take a Lego approach to this, and I'll get into that in a minute too, about kind of assembling these things with bricks. It's a secure cloud-based platform. So initially it was for just specifically the HIPAA, but now we've been increasing the security to meet the CMC level 2 or NIST 800-171. That's becoming more and more commonly seen in some of our grants, as well as working towards ultimately a FISMA or a moderate, which is an even higher level of security. But so we use a hub and spoke architecture, which is pretty common in Azure, where we have a centralized hub network that has the internet connectivity. It's where our VPNs are. It's where the firewall lives, as well as other centralized services that all of these computing environments might use. Like we have licensing servers here. We do centralized logging. We deploy our compliance policies here. And like I'd mentioned before, we have very strict technical and administrative controls that control the movement of data in and out of the platform. And then we've taken a DevOps approach to this. So 100% of this is written in code. So we don't click around anywhere in the screens. Everything is written by code. So that includes deployment of all the cloud-based services. It includes the installation, upgrading, and removal of all software, the configuration hardware, the hardening of operating systems, and everything's version controlled, and we pass it through pipelines. And so this is what that automation looks like. We use something called Terraform, which is our infrastructure as code. That's how we largely manages the cloud resources. Ansible is a configuration management tool that we use to install software, again, update, delete. It also is what we use to harden our operating systems. And the way the pipeline works is a developer then is building this code and creates a feature branch off our production branch, iterates over that. He actually writes test code cases to validate that what was deployed was what was expected. And they iterate until they have something that they think is working. Then they do a merge request. They have the pipeline then does a check to make sure the code's valid. It builds a plan for what changes it's going to make. And then approver, which is usually their peers, review their code and review the plan. And once they approve it, then it builds it and deploys it within our staging or a test environment. And then that code gets merged into our test branch or staging branch. And then we do the same thing once we have a QA person who goes and does the testing. Once we've confirmed that that's tested, there's another merge request that puts it into production. Similarly, goes through checks, it plans it out. And now we have usually management level approval here. So the manager comes in. The key thing here is make sure it doesn't destroy or change anything significantly about the environment. If it doesn't, they approve, builds, and then merges with production. So at any time, our production code branch can be run and we can see if there's any drift or anything else. We know exactly what's been deployed. There's a complete audit trail of everything that's been changed within this environment and who's approved it. And so it requires 2 people to always be involved in any deployments, which is important for our compliance. And so getting back to the building blocks, my lead technical architect here is a big Lego person. He's a master builder. So we use the Lego analogy, which feels appropriate for this. So we have these service bricks, which again are our Azure services that are compute. So VMs or storage, databases, now AI services. We have software bricks, which are again the software that people typically would use on virtual machines like R and Python and all the other SAS, data, et cetera, et cetera. And then we have our compliance bricks, which are the state-of-the-art cybersecurity and privacy tools. I will say that one of the big reasons we did this within Azure and within the cloud, not on premise, is it was the security. It's easy to implement a lot of the security controls in a kind of isolated environment. We had the campuses, Azure or Entra ID or their authentication couldn't be brought up to the level that we needed it to be in our security. So it forced us to have our own tenant. But then that gave us a lot more control to secure things the way we needed to. Now we've been working with on-premise. It's a lot more challenging to get this similar kind of environment set up there. So the way we set up these data science dry lab suites is, again, think about we have these Lego instruction manuals, and the Terraform is our instruction manual. We can assemble all these different pieces together. They're basically reusable code. You provide some parameters, how big, how much disk space do you need, et cetera. and then and which things do you want or not want, what software do you want to install, and then we pump it through the pipeline and it creates these environments. And so these can be, you know, one or more servers. They can be Windows or Linux. Again, we use data. The data movement is done via Globus. We have everything goes initially starts in some cloud storage. People can then copy down the data that they're working on into local managed disks. Then they're computing in their virtual machine, but they have access to databases if they need them. They can access other native services like OpenAI from here, and more of our researchers are leveraging the Azure Foundry AI services that are available. We back up everything, so we keep an OS disk separate from our data disks, so that way it allows us, if we needed to, we can completely destroy an OS disk, because sometimes those do get filled up, and redeploy the OS, and it doesn't impact any research or anything that's been done. And like I said, we can install whatever software they need. We've deployed just about all of the software that we commonly see. We occasionally get new ones. And then this firewall does protect them. So it's largely a deny all firewall out. Sometimes people find that inconvenient, but we do allow access to like common R and Python libraries, as well as our own GitLab instance here at the university. So the other nice thing here, Azure has this kind of an automated security governance using something called the Azure policy, where you can encode our rules into guardrails, if you will. And so we work with our cybersecurity team, and we talk about like what things they're concerned about. Things are, what's publicly exposed. Is this setting turned on or off? Do we want to implement? We force something to be implemented on everything that's in this kind of scope. And then we first build these things again with code. So the policy is code, and we implement these things first in an audit mode, so we can watch them and make sure that it's not going to have an unintended effect for a while before we put them into effect to either deny or remediate. So the deny would be if somebody tries to deploy something that violates the rules, it'll stop them. So this will even happen in our staging environment, where like it won't be able to get deployed because it fails because they were non-compliant. It gives them a chance to fix it. So in theory, it shouldn't happen in production, but if it does, it also gets similarly denied. We also do deploy if not exists. So we often use these for, well, one key place we use this is we put resource locks on a lot of our resources, so they can't be intentionally or unintentionally deleted. And so it takes an extra step to delete anything in here. So we use something called privileged identity management, where somebody has to request access to production and like scoped resource. A manager has to approve that, and then they can go and delete the resource block so that the code can then delete it. But again, that's done so to protect the resources from accidental or intentional deletion. And then we also use it to deploy agents and things like our security agents and things on the VM. So every VM that gets deployed, they automatically get these agents installed via that. And so then we have with dashboards and things that our cybersecurity teams can review and kind of monitor our environment for compliance. And we can also set up notifications and alerts when things are out of compliance. We've also so all this stuff goes into a Grafana instance that we run in Azure. It allows us to build some more useful, easier to navigate dashboards for anybody. But in these cases, there's a couple examples of ones we give to cybersecurity. So the top one is our VM patching, and you can see that they're all currently been patched up. They're all patched up. And then more recently, we built a easier way for them to kind of see what's happening on our firewalls and kind of look into blocked rules in particular they're interested in, things that are being denied. So obviously people have a lot of concern about the cloud because it can be expensive, and it can be, and we do spend a fair amount of money in Azure, but we do a few things to make it put some of the control in the hands of our researchers. So we allow them to change their instance type, and we definitely have had researchers, particularly in the AI space, where they're running a GPU, and when they're doing their development, they can get away with only having a small VM with maybe a modest GPU. But when they want to scale it, then they can resize their thing, spin up one that costs them $1,000 a month or more, and then they're able to do their analysis, and then they can spin it back down, and then continue to do the work they're doing on a smaller VM. And it also allows them to change over time, again, depending on what their needs are, or to experiment. They don't need to know upfront how much computing they can do. We can give them we have some pretty good ideas based on the kind of tools they're using, what kind of compute they should use, but they can increase or decrease those in size. The big thing, right, if you want to save money on computing in particular, is if you're only using these computers like 40 hours a week during the work week, you can save yourself 74% of computing costs. And that's a pretty substantial amount of money. That's the way most people in this environment use them. Occasionally, some people are running long running jobs, but most of the time they're just interacting with this data. And so they're often not even using the 40 hours. And the one thing they do have to recognize is that the disks and the storage are always on you. You're paying for that whether you're using them or not, because they're still storing data. We can also schedule automated shutdowns. So if they want to say at 6 o'clock every day, please shut this down if I haven't shut it down already. So that'll, in case they forget, allows us to save them some money that way. We do something similar with the databases where they can resize them as workloads change. So they may do like a big data load, and then they want a bigger database to compute so that they can process those data more quickly, and then they can resize it down when they're just querying it routine on a regular basis, and then again they can start and stop these databases as well. Again, storage is still always on, but the computing part is something they can control. And then we provide them cost reports so that they can use to monitor and analyze the spend, so they can break down, like look into where they're spending all their money each month. We have a couple different ways of accessing this environment, the virtual machines at least, and it's one of the ways is to navigate the Azure portal, which is not super can be obvious for people who are not familiar with it. So we built kind of a self-service portal, if you will, where they'll see their virtual machines that they have access to. They're able to start and stop them just by clicking this button. If they click this connect button, it'll launch a little web browser that just asks them for their password, username, password, and then it launches the VMs in their browser. That's how many of them use it. So you can also set up a SSH tunnel and then use an RDP session to go directly to it as well. But that requires you to do a few command line things. Just to give you an idea of what our support looks like, we have a part-time application administrator. He also administers our on-premise environment as well, and he does the triaging of tickets, manages the users. So when they forget their passwords or they need to, we have new users, he onboards them, ensures that they've signed their attestations and completed all their training, and then also works on permissions, establishes permissions for them. We have a research facilitator who does consults, like many of you, I'm sure, onboards people on this. They do the training, they provide documentation. And then we have a manager over a DevOps team. We've got about 5 DevOps engineers, and so she manages that team and the sprints and assigns work, and she does a lot of the approvals for the privileged identity management. And then we have our DevOps engineers who do, again, they do coding all day, every day. But we do have a rotating firefighter. So in order to keep most of them focused on their project work, each sprint, so which is a 2-week sprints, we assign one of them to be a firefighter. So when a ticket comes in and the research facilitator, the application administrator can't answer those questions, or it requires an engineer to kind of go in and troubleshoot something, then that's assigned to that person. Otherwise, they do other tasks that they have assigned to them. And then we have a dedicated cybersecurity analyst who does monitoring. He does risk assessments. So when people want to use new services or new tools or want to reach out to something external to the platform, he does a risk assessment on that. When there's potential issues, he investigates that as well. And then there's a bunch of other people that are kind of come and go part-time, like me. I kind of provide oversight and kind of roadmap and direction on the platform, but I don't work kind of day to day. But the one thing that we've learned through this is that there's a steep learning curve in all of this, right? And even our research facilitators, it's enough different about operating in the cloud versus on premise that it takes some time and some training to kind of get up to speed fully on it. And the same happens with our DevOps engineers, even if they're familiar with the cloud. We basically are running a data center in the cloud, right? So you got to know networking and firewalls and databases and VMs and then all the things that are unique to the cloud and key vaults and all these different concepts that may not have been exposed to. So there's some on-ramp time to get people up to speed based on their experience. So what's next? So we are about to go through a third-party audit for cybersecurity. So I'm sure many of you are encountering these more and more. We've been kind of operating in the HIPAA world for a long time. We've got a lot of experience with that. And you can see that usually means about 50 or so technical controls, but we've been slowly working our way up this kind of security thing because we're encountering more and more NIST 800-171, particularly the genomics data, but it's also some of the Department of Defense, the CMMC level 2 is based on the NIST 800-171. Look, there's a controlled access repositories that are using the same standard. So this is becoming a very common standard used by a lot of the federal funding agencies. And then we're also seeing some that are starting to use FSMA moderate or a NIST 853 moderate. So that's ultimately we're working down. So we're expecting to be able to be compliant at this level, but we're curious kind of as to get a gap analysis to know how far we are away from kind of achieving this. But the one big value I think we provide our researchers is that we handle the security so they don't have to. And when they sign these contracts or these grants and agreements with the federal government, they're saying yes, we will be compliant, but none of them have the experience in order to actually comply with these rules, and so they set themselves up to potentially get in a fair amount of trouble. So we handle a lot of this for them. We do make them all sign these attestation documents, just basically reminds them what their responsibilities are in using this, because security is everybody's responsibility, but we do handle a lot of the heavy lifting for all this cybersecurity. And then the other thing that we've been working on, we continue to expand these self-service capabilities. So we've got our service catalog here where people can. Right now, this request just kind of opens up a Jira ticket, and then they can fill out the things. But we eventually would like them to be able to spin up their own just by clicking here, and then here's all the software we have available in Windows and Linux, and they can request or install it themselves. So we don't need to get involved as often. So that's kind of the vision, is to try to make this as simple for our users as possible. And I think with that, that's all I have there. I can't really. So I'm looking at my screen. I can't really see the questions on the screen, but I'm open to questions.
Yeah, I can help filter that. One of the questions, actually, this came from me was, are you using high assurance endpoints with Globus? If you had to configure those?
Yep, we have to use high assurance Globus endpoints. Yep. So
Okay.
we have one of those on premise, and then we have there's connectors that you can set up within the cloud that allows you to connect to storage accounts on Azure.
Okay, nice. All right. What is the SSO authentication used on the internet side? I think is what he's saying here.
Yeah, so we require everyone to get what we call our net IDs with campus. So it's using Shibboleth on the back end. So it's using the campus authentication, which is where we get a two-factor. But we also, because it's in Azure, there's also sometimes a second factor, which which the platform kind of determines, and you have to then also authenticate with Microsoft Authenticator.
Okay. Did try to see who had that question. Was there another side of that question? Okay.
Well, that's great. Thank you.
Okay. Can you comment on the need for VMs versus presumably better performance on containers?
I think VMs were easier for us to set up, I think, because it was just familiar. I will say that we are experimenting with a Jupyter Hub container, like Jupyter Hub based platform on premise that does use containers for even interactive. So like we can spin up a Linux front end, but the problem is, as you saw, that maybe you didn't see, but a lot of these people wanted Windows, and I haven't seen a good, reliable Windows container environment yet that could deploy in Kubernetes. But we use containers quite a bit for our applications for a lot of the internally hosted stuff we do, but we haven't turned that over to users as much. We have been trying to find other cost-effective ways for people to do research, and so we've been encouraging those who can do it to use what's called Azure Synapse, which is basically Jupyter Lab, right? So you can run it R and Python, and so if they could do their analysis in there, then they can share it, use it. There's a shared compute environment that we have that our data engineers use, that they can use as well as a way to save money. But often they want these other tools that they're more comfortable and familiar with, and so that's why we still end up using a lot of virtual machines, because again, we can tailor that to the same experience they'd have if they bought that computer and stuck it under their desk.
Okay. There's a question on what's the user base and the total support team size?
So we have I know it's probably approaching about 400 users. And we have the 5 engineers, the DevOps engineers who build and support a lot of the back end of this. We have a part-time application, what we call application administrator, and then only one full-time research facilitator, and that's kind of the extent of our support.
Yeah, no,
Again, there's other people around. I mean, we do have user support nodes, some help and getting people
right.
connected and things, but that's basically it.
Yeah, Martin, did you want to pose your question?
Sure, yeah. So I'm interested about a financial model, i.e., did your
Right.
school pay for the whole cloud cost? Do you have some chargeback? Do the researchers use, say, their own grant credits or money to spin up their VMs, things like that?
No, good question. And I should have included some of that. So yes, we charge back whatever the part that they use, right? So any of the computing, the storage that they use is charged back to them, and they usually put that on the grants. But the school at the moment does cover a lot of there's probably about 30% of the cost is just the security and the other stuff that the school does cover at the moment. I mean, we're revisiting our chargeback models, but it was trying to ease people into this environment to try to keep the cost as much as you can. And the developers are largely on grants. That kind of comes and goes. So when they're not on a grant, they sometimes shift back over to like university or school funds. But we do try to get researchers are doing some bigger things. So we have some researchers who do like we do a lot of development for them, and then they typically would fund an individual developers. We've gotten some startup funds for the facilitators and the application administrators, but whose time we're going to have to figure out how to start billing back for. So we do anticipate we're going to probably increase the cost of these a little bit. But to give you an idea, like what a typical one looks like, so the people who are just doing some basic analysis, we're talking about less than $100 a month on average, and then it goes all the way up to maybe like really big research programs where we have dozens of VMs and a whole bunch of lots of data and stuff can get into the $10 to $20,000 range a month. And then there's the big AI users who are doing more on VM. So they're running their local models and stuff. They can spend up to, I think, like $1,000 to $4,000 a month. So it varies quite a bit, but I would say the majority of people are spending less than $100 a month.
Also, additional question that Patrick asked, more or less figuring out when is it worth or how big the institution needs to be to create something like what you have created. And so I guess maybe say a little bit more about how this all got started. Did you get some initial funding from your institution, things like that?
Right. So we started small, right? And we started with just some funds from because of our health system partner, they provide a lot of funding for the school. So we probably get a third of our revenue comes from the health system, and they were interested in this. So they kind of gave us some seed funding to get this started. And then we got a couple of big grants that wanted to build this out. So honestly, the bigger grants paid for a lot of the building out a lot of the infrastructure here, but it was definitely iterative, right? We started like, what's the smallest thing we can deliver? And then it's been, I mean, so we've been doing this for 5.5 years now, right? And it started with like, I was actually the first developer on this. And then we hired somebody, he took over, and then it's kind of grown since then. So you can start as small as you want, but the problem is that there's a fixed cost in some of this stuff, right? That's pretty high when you're small. And so you do need to have, you need to have a plan to get this, get people ramped up into this as quickly as you can. The problem, it's expensive. I mean, to get up off the ground, it requires skilled people that know what they're doing, which are sometimes hard to find in the marketplace now. Certainly AI is helping my engineers get even faster at writing the code, but and understanding these things. But yeah, I think you got to be a pretty good sized institution. I mean, the other thing that we've started to do, so the University of Milwaukee is a smaller research. They're more in education than they are research, and they have a couple system engineers who run their HPC, and they were trying to figure out the cloud and realized this is a totally different skill set. And so we spent a day with them just talking through all the things we did, and they, all you did was confirm that this is more than we can handle. So we actually subcontract them, so they hire us and we provide them a computing environment so that they don't have to manage all this. They can onboard their own people. They can help kind of do the day-to-day support, but then we just provide the secure inviting environment for them. So these are not easy things to build. They're expensive, and it takes a lot of experience. So it's not for the faint of heart at all.
Good to know that you're trying to sort of help the smaller institutions. We're in a similar situation here in Utah. The University of Utah being the flagship state university, we're kind of pretty much doing research computing support for everybody else.
Yeah, I think I don't know how it does the same thing, right? And I think it's probably a good model, right? Because the smaller universities can't afford to do this kind of thing. They're
Yeah,
not going to have the expertise to do it. So it seems the right
exactly.
thing to do.
Yeah, so maybe I'll move on to another question. I can continue to give
But
Justin some break. So we have a question about if you have anything in place to protect against supply chain attacks through the dev dependencies.
yeah, so yes and no. So we do install malware and virus scanning software on this stuff. We do when we're working with containers, we all those containers have to be stored. They have to go through a pipeline, and there we do vulnerability scanning, and we do create the bill of materials for all of those things. The other thing that again by design, even if something were to get infected within this environment, it can't phone home because the denial firewalls, because we've isolated these environments, they can't crosstalk. So there's limited impact in the event that something does get compromised. I mean, for us, the most important thing is the identities, right? And so and that's why we use these privileged identities. No one's got the keys to the kingdom. No one can go directly into our production environment and be able to do anything. You have to we have a key vault on campus that requires multiple levels of approval, rotates passwords and things like that. So it's difficult for someone to be able to because that would be the way that in the cloud you get in is just get the keys that are like admin keys, which happens all the time, and then you own somebody's environment. But so the supply chain stuff's always a problem. It's a bigger problem for us on premise, I think, than it is on. And again, we have to find the balance here, right? So we'd like to try to get to a point where we have our own repositories where we can cut them off, like a JFactor Artifactory, for example, or something like that. Right now, we are allowing direct out to PyPy. So if something does get compromised there, it could come down. Again, the hope is that we then isolate it enough that even if it was to get compromised, there's little impact on the research, but certainly an area that's going to be an ongoing problem for us for sure.
Mm-hmm. Maybe I'll ask Steven to ask this question to be a little bit more pointy.
No problem. I'm not familiar with all of the Azure tools sets, but is there some sort of like data tagging or data loss prevention tools you're using like as it's brought into the platform?
Yeah, they have a whole thing called Purview, which they use for that. I think it's more useful when like you have the whole Microsoft ecosystem. So if you guys are documents and things like that where people tag them. So we've done some experimenting with that, but not a lot of use with it. Again, because we can control the data coming in and out, we do. Again, there's an audit trail. We have an honest broker whose role it is to de-identify data or validate things are de-identified, and he has access to all of those things. So manually we kind of do it, and you kind of look for like, hey, that's a large data set, that's odd. Normally people should only be taking off like a Word document or some pictures or things like that. They're not usually taking off large amounts of data. And we've got people doing it,
right?
That's kind of our DLP at the moment.
And then my other question unrelated is kind of how do you approach migrating folks from physical capacity to right-size cloud subscriptions, sort of like depth of support or how involved you need to get involved with those support requests?
Yeah. And this is where, we try to work with the facilitators. They sometimes ask engineers for some guidance too. But and again, this is where it's nice you can resize things, right? So we try to take we can look at what they have on-prem, and if they have enough data that shows like performance over time, we can kind of see if they're sized right. Otherwise, we spin them up an environment that's kind of somewhere in the middle, and then they can go up and down from there to figure out what's optimal for them. And that seems to work. That works pretty well. We don't really run into too much problems. We try to give people some information, and we hope to provide better graphics to see like on system performance too, so they can see, oh, I'm running into bottlenecks with my memory or whatever it might be, and then they make more informed decisions on how to change their VMs too.
Yeah. Okay, that sounds great. I run into folks that look at what's under their desk and they're like, I need this size. So 2 GPUs is ideal. 24/7, anything less is bust. So yeah, thank you.
Yeah, then you show them the price and then they go, okay,
right.
maybe all that.
Yeah.
Yeah, that's how we do it typically. Like, well, let's talk about the most common problem we run into, I think, is that people don't think throughout all the software they need. And so we try to provision, because you're paying for it. So we try to provision the smallest operating systems disk as possible. that still accommodates that, and then they come back later and like, oh, I want this other one, and then it fills up the disk, and then we got to destroy it all, rebuild it all, which is doable, but it's a little inconvenient.
Yeah.
Okay.
Yeah, this kind of takes along Calvin's question, where he's saying if you have any more, put any more constraints around resources to reduce the costs, like checks for inactivity, restrictions to the sizes, or do the researchers need to demonstrate the need before asking for a bigger resource, things like that?
Well, Azure has some kind of built in a little bit because there's limits, like especially the high demand stuff, like all the GPU computing, you've got to request to even be able to provision them. So people can't just actually go out and get whatever they want. So the high end stuff, you got to kind of work with us anyway a little bit on those. We do kind of monitor for inactivity, and more late recently, we've been trying to tell people, hey, we noticed you haven't been using this in a few months. Are you still using it? So try to be more proactive about like we can also spin these environments down, right? So we can keep their data if they want to keep their data and just shut down all the computing. And then again, if they want it back, we can spin it all back up again just by uncommenting the code. Let me think. I don't. I don't. We don't really. We could put more restrictions on those things, but that's never really been. It's not really been a problem at all. I think people mostly are so cost conscious that they try to run it on the least amount of computing possible.
Yeah, that makes sense. Like people control themselves because they see the bill.
Exactly. There's some benefits to that, right? When it's free, then you use all the space you want, use all the compute you want. But when you got to pay for it, you're a little more thoughtful about it.
Yeah, a lot of us are in the HPC world where we kind of provide the resources for free,
Right.
So then you don't have that many incentives.
What's their motivation to be more efficient with those resources, right? Yeah, we run one of those too on premise, but and learning the same thing.
Okay.
Yeah.
Thank you, Mike. That answered my questions.
Oh,
I appreciate it.
No problem.
All right, let's see. Do we have anything else here? I think I ran through the chat, so maybe I'll just
Is
open
anyone
the
else
floor.
operating in cloud environments like this, or even at all, or most of you all working mostly on premise?
So from our perspective, we at Utah, we are spinning up our own 801.7.1 environment now, and it's a lot of pain.
Yeah.
It's just a lot of controls. We have an old HIPAA environment we've been running for a decade now, or more than a decade, and that's pretty usable. This new one is definitely much more controlled, and so we're very slowly onboarding users to it, and we don't really have a good workflow. And there is some discussion on a campus level to create some sort of a cloud prototype as well, kind of in parallel, just so that potentially people have a choice. But we are more focused on the HPC part, so we're not so much on the services, and so that I think the services kind of need to be in a cloud really to be persistent, right? And things of that sort. So let's see, we have Calvin saying mostly on-prem, some cloud, but not many formal services. Justin saying they have using Azure for CMMC2. We have one question from Carl. I'm wondering how might others replicate this if the system code is the system code shareable with, say, a license or NDA versus open source? So I guess basically,
I would personally, because it was me, I would open source this because I've benefited so much in my career from open source stuff. But there are people here who are always looking for opportunity to bring some more revenue into the university. But happy to talk to you about, if you want to send me a note specifically, I'm happy to talk about what we might be able to work out though. Yeah. I think there's a bit of it too, where like our cybersecurity folks are also a little like, if you put it out there, it's, the AIs or others can just mine that and see if there might be flaws in our design and might be able to use that to their advantage. But I mean, that's also sometimes seen as good, right? Because it exposes that to a lot more eyes. But we might be able to do something on in a point-to-point sharing at some point. It's complex though, I must say. So hopefully you're ready for the learning curve.
All right, Patrick asked a question. As we see researchers engaged in more multi-institutional applied research awards, we're seeing more ask for cloud compute. Yes, so I guess that's a whole new can of worms. Like, how could you enable this for multi-institutional kind of collaboration? But
yeah, and we do have a lot of these research projects are multi-institutional. So one of them is they have like 23 collaborators across the other institutions that collaborate with them on it. So we do bring people from the outside. we set up ourselves perfectly accidentally when like Microsoft entered into the agreement with OpenAI that we had a secure environment. So nowhere else on campus could you work with these LLMs based on policy except for in our environment because we'd secured everything early on. That's starting to change now, but obviously the other thing that was advantageous for us is that I didn't have to go out and buy several $1 million of hardware to get started, right? We could start small. We spun the things that we're doing development. We were spinning things down, up and down all the time, and largely weren't running anything while we worked through all these processes, right? So the costs early in the early days in the computing was small, and so that's the one nice thing about the cloud, right? Is that it's the compute on demand. I mean, it doesn't require the upfront investment, but and maybe it is a little. And again, we have our own on-prem HPC too, right? It doesn't make if you're running 20 GPUs that they would cost you a fortune in the cloud, and it doesn't make sense. But and a lot of the GPU stuff that we were doing early on was before we had our on-premise secured environment, so that's why people were doing it in Azure.
All right. Does anybody have anything else to say? We have pretty much filled the hour, and it was really useful from my perspective to see somebody that actually has working environment in the cloud like that. Because again, the secure compute environments are a big challenge for everybody now. So
for sure, yeah. And again, if anyone has any more questions or would like to talk about this any further, my contact information was in the sign-in log there.